This is Srikanth as Assistant Professor of EEE Department. In this session, I am going to discuss the operation of diode as a switch. The diode will work as a switch because diode will work when there is a forward bias. The diode will act as a short circuit. When there is a reverse bias, the diode will act as a open circuit. So by making forward and reverse biasing of the diode, which will makes the diode as a switch. The diode is a two-terminal semiconductor device which has PN junction. When the PN junction is forward biased, then it acts like a closed circuit. Forward bias means which is going to have the conduction from anode to cathode. When the conduction is there, it acts like a short circuit. So it is operating like a switch under on condition. When the junction is a reverse bias state, the diode acts as open circuit because no conduction will take place. So when there is no conduction, it will act as a open circuit. So with the reverse and forward biases, the diode can act as a switch. Where PN junction diode acts as an electrical switch. This type of switches are called electrical switches. The main advantages of electrical switches over mechanical switches. Where mechanical switches are going to have movable contacts which we need to on and off. So for that, which is required some maintenance because moving parts are going to may get damage. So which require some maintenance of the switch. And the contacts of mechanical switches are made of metals and exposed to the environment. When the contacts of switches are made with metals and it is exposed to the environment, which will adopt the oxidize. That is, there is a contact oxidation. We are going to get the problem of contact oxidation, which will lose the property of the switch. The mechanical switches undergo more stress and strain comparison to electrical switches. The wear contacts of mechanical switches affects the working and thus they are not reliable. So generally we are going to affect what are the mechanical switches, the contacts are going to affect the working after certain time period. Performance of the switches are going to changes, so those are not reliable. So power loss across contact of the mechanical switches is more than the electrical switches. What are the power loss which we are going to get across the two switches? In the electrical switches, the power loss is less. The switching time of mechanical switches is more as compared to the electrical switches. The principle of working of diode as a switch is nothing but forward and reverse biasing the diode. When a forward voltage is more than the cut-in voltage of the PN junction diode, the current flows through the junction. Thus the diode junction becomes a short circuit. The diode comes in the reverse bias when the voltage at the diode's anode is more negative than the voltage at the cathode. In this condition, the diode junction is an open circuit. Here, this diagram shows the working of diode as a switch. Here, for understanding clearly, the diode connection is given in the both the directions, that is with forward bias voltage and with reverse bias connection. So here this is a forward bias voltage which is connected in series with the resistance R1 and which is connected to anode, and cathode is connected to the negative of supply. When this voltage is applied, when the forward voltage is applied, the current will start because anode is connected to positive and cathode is connected to negative. So the conduction of electrons will take place from anode to cathode. So the diode acts as a short circuit. So the current will flows from voltage R1, anode, cathode and voltage negative. This is during the forward bias condition. When we want to go with the switch off condition, that we are going to shift the circuit breaker, whatever the contacts, circuit is shifted from this side to whatever this arrow mark to this dotted arrow mark side. So here the negative voltage is connected to the anode, positive voltage is connected to the cathode. So when the negative voltage is connected to the anode, the diode acts as a reverse bias. When the diode is acting as a reverse bias, it acts like a open circuit. No current will flow. No current will flow. Here, a diode has a PN junction. In a diode, P region has lightly doped holes as the majority carriers, and N region has highly doped electrons as the majority carriers. When the switch is at on position, the anode of diode D gets a positive supply and the cathode of D gets a negative supply. In this condition, the diode gets forward biasing and it starts conducting. Now, when the switch position change from on to off state, the anode of the diode gets the negative voltage at the anode. Under this condition, current that was flowing in the forward bias state drops to 0, because when we are shifting from the forward bias voltage to reverse bias voltage, whatever the current which is there in the forward bias state, that will reach to 0 and then the diode becomes open circuit. Here note that the diode forward current does not drop to 0 instantly, but it takes some time. The diode current will not become 0 instantly. It will take some time because of a junction current, because whatever the electrons are there, whatever the energy is there in the junction, that has to move completely, move to 0. Whatever the electrons should reach to 0 position. This time is called reverse recovery time. This time is called reverse recovery time. Now the diode draws negligible leakage current in the reverse bias. Now here the diode will draw some leakage current in the reverse bias condition. Here is the how a forward bias diode will work as short circuit and reverse bias diode will work as open circuit. It is clearly shown. Here the forward bias voltage anode is made positive with respect to cathode. Then immediately the diode will act like a short circuit. There is complete conduction from anode to cathode. And here if anode is here anode, cathode, when here anode is made negative and cathode is made positive, then when anode is made negative, then the cathode then the diode will act like a open switch, that is open circuited diode. When it is open circuited, no current will flow through the diode, so the diode current is 0. Now, what is ringing in diode? A phenomenon of ringing happens when the diode undergoes from forward bias to reverse bias state. Here ringing is nothing but when we are shifting from forward bias to reverse bias, that process is called a ringing. And the application of reverse bias voltage to the diode after the current flow, the reverse current flows for an instantaneous movement rather than instantly switched off. Here, once immediately we are shifting from forward bias condition to reverse bias, whatever the reverse bias, immediately the diode will not get open circuited. It takes some time to get open circuit. That is because of a reverse recovery current. During the flow of recovery current, the recovery current may create few oscillations, where these oscillations are called ringing. During this process, because reverse voltage is applied, so because of that, we are going to get some oscillations in the current. These oscillations are called ringing. The ringing condition causes power loss, and it is desirable to have minimum ringing. That is, these losses will create some power loss. So we have to see that there is a minimum ringing. And the switching time is very vital part of an ideal switch. The switch must have shortest turn on and turn off time. Now let us understand the switching times of a diode. Now let us go through what are the switching times of the diode under forward bias and reverse bias conditions. Now, while charging the bias conditions, the diode undergoes a transient response during the forward bias to a reverse bias. Whenever we are switching from on state to off state, how the transients are going to affect. In the same way, in the diode also, when we are shifting from forward bias to reverse bias or reverse bias to forward bias, there will be a transient response. It takes some time to respond whatever the input which is given. So the time taken to respond under transient conditions is important criteria for an electrical switch. What is the time taken to switch on the diode? That is nothing but whenever we want to make it forward bias, what is the time required for an electrical switch is very important, because once if we switch on, it takes 10 to 20 seconds or 30 seconds or more than 1 minute. That is not a perfect switch. When we have switched on, immediately within a short time, 1 or 2 seconds, it has to switch on. That's why we have to reduce the ringing of the diode. Recovery time. Here, recovery time is nothing but time taken before the diode recovers from its steady state is called a recovery time. Here, time taken before the diode recovers its steady state is called recovery time. And forward recovery time. The time taken by diode to switch from a reverse bias state to forward bias state is called forward recovery time. In this, we are having in the recovery time forward recovery time and reverse recovery time. When the diode is switched from a reverse bias to forward bias, state is called the forward recovery time. Here you can see when we have given the input, it takes certain time to reach the maximum value of current, This period is called forward recovery time. And the application of forward biasing is an off-state diode. The voltage across the diode instantly shoots up to about 1 to 2 volts before settling down to its final value of 0.7 volts. This is our cut-in voltage in order to turn on the diode of 0.7 volts, but injection of minority carriers takes some time. Here the time taken to cross 10% of the final value to the peak and to the final value is called forward recovery time. And here now we are considering an important consideration in the selection of diodes for switches. For fast acting switching diodes, it should be about whatever the timing should be 50 nanoseconds. And the next one is the reverse recovery time. Here reverse current flows from a small period of time when diode is conducting and suddenly it turns off. The time interval taken by the diode to switch from a forward bias state to the reverse bias state is called a reverse bias. Here when the diode is under switch on condition, that is nothing but forward bias condition, and it is shifting to a reverse bias state, then that whatever the time taken from forward bias state to reverse bias state is called reverse recovery time. And the reverse current is called reverse recovery current. Here you can see the reverse recovery time. This is the time taken to reach the negative voltage, that is nothing but complete current is reduced to zero, it is open circuited. When it is open circuited, the negative voltage is applied across the diode. Now the recovery time is in order of few nanoseconds to a few microseconds or even more. And it all depends on the device and the current level. Whatever the reverse recovery time, it depends on whatever the material we have used for diode and what is the doping level and what is the input which we have given under forward bias condition. There are certain parameters which depends on the diode switching times, that is reverse recovery current and reverse recovery time. So here the minority charges require time to recombine with majority charges in the depletion region. So this will cause a significant power loss in the switching regulators. Now the storage time. Here the time period for which the diode remains in the conduction state even in the reverse biased state is called as storage time. Until unless the current zero happens. Here you can see up to from here to here, whatever the, even though there is a reverse voltage which is applied at this point T1, up to T2 diode is in forward bias condition. That means conduction is taking place in the diode from anode to cathode. So, and that time is called storage time. Now, using a diode as a switch in electronic circuits is a common application, and it involves exploiting the forward bias and reverse bias characteristics of diode. And under forward bias condition, when diode is forward biased, positive voltage is applied to anode and negative voltage is applied to cathode. It conducts electricity. In this state, diode behaves like a closed switch, allowing current to flow through. So, when the diode is forward biased, it acts like a closed switch. And voltage drop across the diode. There is a small voltage drop across the diode, typically around 0.7 volts for silicon diodes. And this drop should be considered in the circuit design, because for every diode there will be some practical conduction voltage drop will be there. That voltage drop we need to consider while designing the circuit. And reverse bias, the diode blocks current which acts as a open switch. When the diode is reverse bias, that is nothing but negative voltage applied to the anode and positive voltage is applied to the cathode. It does not conduct electricity. In this state, the diode behaves like an open switch which is blocking the current flow. Now, the application as a switch. Here, series connection for on and off state. Connect the diode in series with the load. Whenever we want to use the diode as a switch, we need to connect the diode in series with the switch. When the diode is forward biased, the circuit is on and the current flows through the load. When the diode is forward biased, the circuit is on and the current flows through the load. When the diode is reverse biased, the circuit is off and the current is blocked. Now let us take the example. Consider a simple circuit where a diode is used to control the current through LED. When a voltage is applied in the correct direction, the diode conducts and LED light is going to lights up. Here the load we are going to use as LED light. When the voltage is reversed, the diode blocks the current which will turn off the LED. Now, the considerations what we need to take is, first one is voltage rating. Ensure that reverse voltage across the diode does not exceed its specifications to prevent breakdown, because when there is a breakdown occurs in the reverse bias condition, the diode may get damaged. So we have to ensure that reverse voltage should be within the limits what the manufacturer has given. And the diode type, we need to choose a diode with suitable characteristics for your applications, either signal diode or Schottky diode, whatever the diode which is required and what are the characteristics you need. Based on that, we have to choose the diode. And the voltage drop, here we need to consider the voltage drop across the diode when designing the circuit, because there will be a small voltage drop across the forward bias diode around 0.7 volts. and that voltage we need to take into consideration while we are designing the circuit. And these are the applications of diode switching circuits. Here the diode is used as switch for the following applications: high speed rectifying circuits, high speed switching circuits, radio frequency receivers, general purpose applications, consumer applications, automotive applications, telecom applications, etc. In this session, we have discussed the diode as a switch and what are the applications of diode as a switch. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.